All right, so today we're going to look at finding areas of composite figures. I enjoyed walking around and listening to different groups talk about how it is that they were going to do this. Almost everyone started with the same idea to start with, at least that I noticed. People said they were going to find the areas of these two triangles, then the area of this rectangle, add all those together, and then subtract the circle, because the circle's not part of the lawn, it's the pond. So if you're doing that to show work, which you should be practicing doing, if you really want to show work, you would write out the formula every time you used it. So half base times height. If it's this triangle, I can use 3 as the base and 20 as the height. That's 30. The other triangle would be half of 8 times 12 is 48. And then the area of the rectangle is 12 times 20, it's base times height. Is 240. If I add all those together, let's see, that's 78, so that's 318. Then minus the area of the circle. Well, how do we find the area of the circle? Well, that's pi times the radius squared. So it'll be pi times 5 squared is 25 pi. If you estimate 25 pi, it comes out to be 73.5? 70 what? 78.5, thank you. So this ends up being 239.5 square feet. So, question? Especially since this is a circular pond, I would probably tell her to get at least 250 square feet, because you're going to lose some, because your rolls, are going to be, when you roll them out, they're going to be rectangular, and you're going to have trouble with losing bits and pieces around the pond. Okay, now, the other way to do this, and it was fun listening to some of you figure this out also, you could take the area of the whole big thing, then subtract out, either do like this and subtract out the triangle and the trapezoid, or you could do like this and subtract the 2 triangles and the rectangle. Whichever way you want to do it is going to be fine. Just to show you, it should come out to be the same. For the big rectangle, it would be 15 times 28. Let's see, that's 300 plus another 15 times 8. Does that come out to be 420? I'm trying to do this in my head, and I'm not very good at it. 420? Thank you. And then I'm going to find the areas of all these things. We already know the area of this is 30. We already know that the area of this is 48. That's 1 point in the favor of not doing it as a trapezoid. And then this one is 8 times 3. Is 24. So adding those together, that's 78, 88, 98, 102. So that would be 318 minus the area of the circle, which you guys said was 78.5, and we end up with the 239.5. So there's frequently more than one right way to do these. This is one of the reasons why I like geometry so much is because most of the time there's more than one right way to do the problem. I like having that freedom. Now, some people don't. They're like, show me one way to do things. I don't want to have to think about all these other things. I like that there's more than one thing that can happen. I actually told someone the other day, if you really want to make me quit, make me teach Algebra 1 all day. Ugh. Algebra 1's fine, but it's so hemmed in sometimes. All right, let's go on to the back. So let's find the area of a typical basketball court shaded in the diagram at the right. Give both an exact answer and by using 3.14 as an approximation for pi. And we're going to practice showing our work clearly. So let's think about what we need to do here. Clearly there's no subtracting on this one because there's nothing that's not shaded. But what two things do I need to add the areas of together? Not quite. There we go. Half the circle, right? And the rectangle. So I need the area of the rectangle plus the area of half of a circle. So for the area of the rectangle, that's base times height, plus, if it's half a circle, it's going to be half of pi r squared. For the rectangle, base is 19. What is the height going to be? Why 12? Yes, right. And the radius is half the diameter. So this is going to be 12. So it's 19 times 12 plus half times pi times the radius squared, which was 6. See, that's 190 plus 38 is 228. Plus, what do I do first in this calculation? Yeah, square the 6, that's 36. Half of that is?
18.
There we go. That took a little longer than I thought it was going to. 18 pi. So this is the exact answer, and it was in feet, so my units are square feet. I have to put that in parentheses so that the square feet applies to the whole thing. It's not 288 minus 18 pi square feet. It's 228 plus 18 pi, all square feet. Okay? And then, so this is the exact. So then the area will be approximately equal to, let's see, it says use 3.14 for pi. So we're going to multiply that times 18. So it'd be 228 plus 56.52. Which would be 284.52 square feet. Okay, questions about that? All right, so let's look at this one. Gina designs and makes her own clothes. She drew the diagram below of the fabric she needs for the front and the back of a new shirt. If each unit on the grid represents 1 inch, how much fabric will she need? A lot's not exactly a
A shirt amount.
All right, please go ahead and try this feel free to work with the people around you like you did on the first one. Let's see if we can get some agreement. I will point out that the area that's shown there is just the front and the sleeves. And the front of the sleeve, you need to double everything. Okay? All right, I'll give you guys a couple minutes to work on that. See what you can find.
What if some of the grids are chopped off?
I'm sorry?
What if some of the grids are chopped off?
I want you to do the best thing you can do to find the area. All right. Y'all have a good day. Just just in case you're curious, it's about 600, a little less than 640 square inches. Y'all have a good day.